everybody, Mr. Calbeck here. We're going to talk today about more solving quadratics. Again, quadratics, remember, are, remember quadratics are the name of the equation that gives you a parabola. Quadratics, as you may recall, are always written in this, can always be written in this form, where if you have your y value, sometimes we call it f of x. Don't be tripped up, that means the same thing as y. It can always be written like this. So you've got a number next to x squared plus another number next to x, and then another number by itself. So ax squared plus bx plus c. You can always write a quadratic in that form, but that's just the name of what we're talking about here. And I'm going to see what you guys remember about solving these. We've been spending a lot of time on them before. So I have a quick warm-up for you. I want you just to take a few minutes to try to solve these on your own and see what you can handle with this. So they're going to get progressively more challenging and progressively newer based on what we've done. So your first question, I'd like you to try is to solve this. Solve by any means that you remember how. Number 2 is going to be a little trickier. Let's move that down just a little bit. All right, and number 3 we talked about yesterday. Let's see what you guys can do with number 3. But go ahead and try this on your own. Take 5 or 10 minutes and see if you remember how to solve all of these. As a clue, each of these will give you 2 answers. So go ahead and try those. Hit pause, see what you can come up with. Why are you still watching this? Press pause, try them. All right, great. Glad you're back. Hopefully you guys did a good job on this. So the strategy for number 1 and number 2 is to factor both of these. Number 1 is the easy kind of factoring because there's no number next to x squared. So if you factor it, you should have ended up with x minus 5 and x minus 2 equals 0. Again, I'm not going to talk about factoring on this video. I have a whole series if you would like to get some practice on factoring. There's a link in the description. Also, that particular series is a different way of factoring than I taught you in class. In class, I taught you about the generic rectangle. In the videos, it's another way of factoring called grouping. So if you don't like the generic rectangle, you can certainly try a different method. All right, so if I have this, I can use the zero product property because I know that 2 things that multiply together to be 0, that's one thing. There's a multiplication symbol between those, and that's another thing. I know that those, when you multiply them together, have to equal 0. One of them or both of them has to be 0, so I can go ahead and write 2 separate equations. Since there's nothing going on in those parentheses, I can just take them away. And here's the other one. And you can solve. This is pretty easy. Add 5 to both sides, which gives you 5 equals x. Add 2 to both sides, 2 equals x. And those are my answers for number 1. You might even put a little and in there. All right, for number 2, this is more challenging because there is a number in front that does not factor out. So you have to use a generic rectangle or some other method to factor this. If you do that, you should end up with, again, that's going to be 2x minus 1 times x minus 3. If you factor it like that, you will get the correct answers. Same thing as before. Remember, we're using the zero product property. Both of these multiply to be 0 again. So I can set each of them equal to 0. 0 equals 2x minus 1. And 0 equals x minus 3. Set each of them equal to 0. Solve. This first one's a little trickier. There's one extra step. You have to add 1 to both sides. And then divide by 2. Because there's a 2x. You actually get 1/2 here. And the other one, you just add 3. So you have 3 here. Again, if you're watching this and you don't know how to factor, I recommend I'll put the link in the description. Last one here we talked about last time is this problem right here. Remember, we want to use Pemdas backwards. So if it's helpful, go ahead and write Pemdas off to the side and just kind of follow it. Normally we start with parentheses, but since we're undoing the equation, we're solving for x, we work backwards. We're going to work backwards here too. I'm going to add 32 both sides because I'm starting with subtraction. So to undo subtraction, I add, which gives me 32 equals 2 times x plus 3 squared. And remember that 2 is being multiplied. So since there's no other adding or subtracting in that's not inside parentheses, I'm done with those parts. Now I'm at multiplication, division. So the opposite of multiplication is division. Divide by 2. 32 divided by 2 is 16 equals x plus 3 squared. Then I am now at exponents. So the opposite of an exponent is a square root. So I'm going to square root both sides here. Those squares and square roots cancel out, leaving me with the square root of 16, which is 4. And remember, anytime you take the square root of a variable, you have to think about a plus or minus possibility. So I'm going to say plus or minus 4 equals x plus 3. And that's two equations, remember. I'm going to go ahead and write them up over here. I have the positive case where you have 4 equals, that's the positive 4 equals x plus 3, or you have a negative 4 equals x plus 3, and you can now solve this. And again, if you wanted a discussion on why there's a plus or minus here, that's in the previous video as well. So I'm going to go ahead and subtract 3 here, which gives me a positive 1 equals x. And then over here, if I subtract 3, I end up with a negative 7 equals x. So there's my two answers, 1 and negative 7. And that's it for your warm-up today. Hopefully you got all of those right. If you didn't, again, watching some of that other stuff would be helpful. But I want you to notice a couple of things on all of these problems here because this is going to be important for today. Every single one of these, and again, starting to get a little clutter on this page, I apologize. So we'll look up here. Every single one of these, I can only solve them if they equal 0. If they don't equal 0, I can't solve the problem. Okay, because the 0, when this is 0, that's where the x-intercepts are. Remember, because the x-intercepts happen on any parabola where y equals 0. And it doesn't matter what your parabola looks like. Every x-intercept, the coordinates, x can be anything. But y is always going to be 0. So it doesn't matter what x is, but y has to be 0 for every possible x-intercept. The y-coordinate is always 0. So if you don't have a 0 on one side, you have to do some algebra first to get 0. And that's what we're going to be talking about today. You have to have 0 over here. If you don't, you can't even start the question. So don't try to do some weird algebra that no one has ever taught you. Don't make something up because you didn't think about putting 0 there first. Okay, so let's talk about what this might look like in a problem here. So I'm going to give you a challenging one. So we're going to take a look at this right here. X squared plus 2x equals x plus 2. Now I'd recommend you can try to solve this. If what I'm saying makes sense to you, go ahead and press pause and try it. Otherwise, just keep watching. Yeah, go ahead, try it on your own. Don't watch me. All right, so this problem is a little different because it does not equal 0. Uh-oh. Okay, what are we going to do with it? That means we need to get 0 on one side first. And the side that I always choose, I always want to keep my x squared positive. Don't touch your x squared unless it's negative. Try to keep that positive. It's going to make your life a lot easier if it is. And if I want to get 0 on one side, right now, this side is what I'm going to be touching. This is the side I'm going to try to mess around with until I can get 0. So I want to do the opposite. Right now, this is a positive 1x. Don't forget your ninja ones there. So we have a positive 1, so I'm going to subtract 1 from both sides. Once I've subtracted that, I now have 6x squared plus 1x equals 2. And I'm still not there yet. So I need to, this is not equal to 0. Again, you can't do any math on it until you get 0. So I'm going to subtract 2 from both sides, which gives you 6x squared plus 1x minus 2 equals 0. Now it equals 0. Now we can factor it and use the zero product property again. I'm going to let you guys try that on your own. Actually, I'll go through this one just to make sure that you guys are doing the right steps because it's been a little while. If you remember how to factor, go ahead and do this on your own. If you needed a quick refresher, I'm going to take about 2 minutes and do this one here like we did in class. Okay, so the first step is we want to draw our generic rectangle. Remember that this is always going to build a rectangle. Our 6x squared goes in the bottom. Our negative 2 goes in the top. And we remember that the diagonals will always multiply to be the same thing. Both diagonals. So I'm going to multiply these two together, which is going to give me negative 12x squared. And it has to add to be the middle term here. 1x. Sorry, 1x here. So this other diagonal is going to add to be 1x. It's also going to multiply to be negative 12. So we have a little diamond problem here. The top is multiplying, the bottom is adding, and you try to find the answer to this. If you can't, brainstorm. Just say, okay, what multiplies to be negative 12? And come up with every possibility you can think of. 1 and 12, 2 and 6, 3 and 4. Remember, one of these has to be negative and one has to be positive because it multiplies to be a negative. I want to find one that adds to be positive 1. 3 and 4 would work if the 3 is the negative one. So to make this a negative 3x and a positive 4x, that goes in the diagonal here. And once you have that, that's the hard part. Now we just got to find the greatest common multiples. So the greatest multiple that goes into 3x and 6x squared is going to be 3x. Remember, the outside multiplies to be the inside. So 3x times what gives you 6x squared? It's 2x. 3x squared times negative 1 gives you negative 3x. 2x times 2 gives you 4x. And you can always check because the outside numbers should multiply to be this last one, and they do. So we have it. So we've got 3x plus 2 on the bottom and 2x minus 1. And that still equals 0 because we're just rewriting this equation here. That's all we've done. Now we can use the zero product property again. Set them up. 3x plus 2 could be 0, or 2x minus 1 could be 0. And then you just solve it. Subtract 2 from both sides. 3x equals negative 2. Add 1. And you can divide here. So with x equaling negative 2/3 and 1/2. Okay. Remember, you have to have 0 on one side or this does not work. Okay, but there are other things that you can do with these. So we could take a look at some other, maybe more challenging questions. For example, let's try a couple of these here. Let's do x squared minus 55 equals 26. Go ahead and try that one on your own and see what you can do. And there's lots of ways to solve this. So see what you can come up with. Go ahead and press pause right now if you haven't already. All right. Now there's two things that you can do with this one. Again, there's two different strategies you have now. I talked about getting 0 on one side first. Never a bad idea to try it. if we subtract 26 from both sides, we end up with 0. So we have x squared minus 81 equals 0. And you can try this one. This actually factors. Woo, awesome. It's a difference of squares, something squared minus something else squared. So it's that plus or minus pattern. And you take square root of both sides. So x squared is x, square root of 81 is 9. Which tells you that your answers, if you use the zero product property, would be 9 and negative 9. Okay, that's one way to solve it. The other way to solve this, same exact question, is to think about it in terms of algebra, and we can do the opposite. Okay, so what we did before is in something in standard form, we just solved it with algebra. So I'm going to actually add 55 to both sides here. You have x squared equals 81, and you can take the square root of both sides. And again, what I'm doing here is I'm saying, all right, something squared equals 81. Now there's two possibilities that could go in there. You could have a 9, because 9 squared is 81, but negative 9 is also a possibility, because negative 9 times negative 9 is also 81. So this actually is going to give me a plus or minus 9, which is actually the exact same thing that I got here. Okay, two different ways of solving the same question. Whether you're using algebra or you're trying to factor, if you're factoring, remember you got to have that 0. If you don't have 0, you don't have anything. If you're using algebra, think about doing the reverse of Pemdas as a great way of solving this. A couple other situations you might encounter that could be a little bit strange. Let's go ahead and show you one. Let's do an algebra one. So let's do x plus 3 squared times 2 equals, wait, sorry, I'm writing my problem down wrong. That's a plus sign, plus 8. There we go. There's my standard form equation, or vertex form, equals 0. Okay, this is 0. You're solving for the x-intercepts here. Great. Whoop-de-whoop. Let's solve it. We want to use reverse Pemdas. So I'm going to start with my really terrible addition sign here and subtract 8 from both sides. Negative 8 equals 2 times x plus 3 squared. And I can actually divide this because it's being multiplied. So I'm going to divide by 2. And then with negative 4 over here equals x plus 3 squared. All right. And I want to take the square root because now I'm on exponents. So I'm going to take the square root. And I have a problem here. And you're welcome to type this into your calculator if you don't believe me. But square roots, you can't take the square root of a negative. Because what we just talked about in the previous question, remember, we were looking for mysterious numbers. And so what I have here is the same sort of problem. I've got something squared. Something squared equals negative 4. Now we got to think of a number that could work in this. A lot of you are going to want to say 2. Well, 2 squared is positive 4. But here's the problem. Negative 2 is also, when a squared, is also equal to positive 4. There isn't any numbers, so far as you know, that equal negative 4. For those interested in the real answer to this, I did a whole video over spring break on being able to do, I think it was the first video I did, about how to actually solve this problem. But as far as you know, in Algebra 1, there is no solution. What we usually say is there's no real solution. Real is a terrible name, but it's what we use in math to represent the regular numbers. And so we'd say there's no real answers, no real solution to this. So if you ever see you have to take a square root of a negative, you can just write no solution and you're done with the problem. What that looks like in a, if we were to graph this, this is a graphable quadratic. if you want to graph it, we know that the vertex is going to move 3 to the right and up 8. And it's twice as steep as a normal parabola, so be kind of skinny here. It's just floating up there. There aren't any x-intercepts. There's no places on this graph where the value equals 0, which is what you're seeing here. There aren't any x-intercepts, so it makes sense that there would be no solution. So be careful of that. There can be situations where you have no solution here. You can also use your calculator to solve these kinds of questions. Okay? So if I want to use my calculator here, I can plug something in. Let's do a pretty simple one here. Let's just say you're freaking out and you don't know what to do. Actually, that was a good one. Whatever. We'll do x squared minus 16. And maybe you just don't know how to solve these. So I can show you real quickly how to do it on your calculator. Let's see if I can get this a little bit sharper focus for you. We can hit our graph. Remember to always check your window to make sure that this works. And I can see here that I can't see the bottom of my graph, so I'm going to change my window a little bit. To make it smaller, I want to go to y min. That's the lowest part of your graph. I'm going to start by making it negative 20 and just see if I can make that work here. I'm going to change my scale as well. Okay, so now I can see the whole graph. If you want to try to find the x-intercepts of a parabola, if you want to solve your quadratic, I'll show you a quick way to do this on your calculator, which is kind of cool. And there are other ways to do this on your calculator as well, but this is one that's built into every graphing calculator. You can also download programs that will do this or write them yourself if you're getting creative on your quarantine. So see the second button here on trace says calculate, C-A-L-C, calc. Hit second calc. And we want to try to find the x-intercepts. There was another word that I've used to describe x-intercepts before, and that was the word zeros. So I'm going to hit 0 here. And it tells me left bound. Now, what that means is you can move your cursor left and right. And what I want to do is I want to move my cursor to the left of the x-intercept I'm trying to find. It doesn't matter how far to the left, just has to be to the left a little bit, or it can be a whole bunch. It actually doesn't matter. Just has to be to the left of it. So I see on my cursor now is to the left of this x-intercept right here. So I'm going to hit enter. Then it's going to prompt me for the right bound. So I'm going to move my cursor, same thing, but I'm going to move it to the right this time, the right of the x-intercept. Notice here, it's now to the right, and it left me a little cursor mark where I hit enter last time. Now I'm going to hit enter again. And you should see two little arrows bracketing your x-intercept. Your x-intercept should be between those. If it's not, you'll get an error message. And then it's going to prompt you to say guess. You want your calculator to try to find every point between your two cursors, and it's going to look for a place where y equals 0. You're going to hit enter a third time, and it's going to give you that x-intercept of -4, or a 0 of -4. If you want to find the other one, just do it again, and go to the other side. So the left of this side, if I move my cursor, it's going to be over here someplace. So I'll hit enter. To the left of the x-intercept. The right is going to be over here. And I'm going to hit guess again, and it will tell me the other x-intercept is +4. Okay, cool way to do that. There's other things that you can use with this calculate function. The same type of thing. If you want to find where the vertex of your parabola is, you can use the same strategy. The vertex in this one is a minimum. It's the lowest point on the graph. So I'm going to go to minimum. And I can see on the graph that the minimum is down here, the vertex. So I'm going to go to the left, same sort of thing. I want to go to the left of the vertex, hit enter. Go to the right of the vertex, hit enter again, and then it's going to ask me to guess. And what it will tell me is the minimum point or the vertex. Notice here my calculator gave me a very strange answer. You can see the x value. It says 1.3389, and then there's the letter E, -6. If you write that down on a test or a homework assignment, I guarantee your teacher will give you 0 credit for that, because that tells me you don't understand anything. If we look at the cursor, it's pretty clearly on the y-axis. which should be 0 for the x value. The e on your calculator, if you ever see that notation, again, here's 1.33 whatever, then you see the letter e negative something. What that means is, this is short for scientific notation. This means 1.33 times 10 to the negative 6th power. If you're familiar with scientific notation, that means that this is a really, really small number. Okay, so what this really means is I would have to move my decimal point 6 places to the left. 1, 2, add a 0, 3, add a 0, 4, add a 0, 5, add a 0, 6, add a 0, and that's where my real decimal place is. What this actually means is this is 0, 0, 0, 0, 0, 1, 3, 3. Okay? What do you suppose that number really is? That's 0. Okay? Your calculators will occasionally give you artifacts like this due to the programming and the way that it works and how it checks numbers. What this means is 0. Please put 0 on your answers. That is the correct answer for the Vertex. This is not more accurate than your math is. Trust me on this. This is not the Vertex. This is an error in your calculator. But keep in mind, your calculator is off by 1/1,000,000th of a point. That's not too bad. So please, please, please do not write this. It is the wrong answer. 0 is the correct answer. And so if you ever see something e negative a big number, it's always going to mean 0. If you see e in a positive number, then you did something really, really weird. Please don't get that. All right. That's it for today. Hopefully you guys learned something, give you some practice problems on this assignment. Good luck to all of you out there. Feel free to keep asking me your questions as you're working along here, and I'll talk to you soon.